All right, guys, this is the 3.5 video notes on graphing linear equations with slope-intercept form. Right off the bat, I want you to, we're not really creative in math. When we write slope-intercept form, I want you to think why we write it that way. It's going to give you a big hint on how we're going to do these. So yeah, just think about that. Quick reminder, I'll go through this one real quick. We want to write y as a function of x. Basically what we're saying is we're just trying to get y alone, right? So here, if I subtract 5x on both sides, I get y equals 8 minus 5x, right? So now we're written y in terms of x, right? In order to get to a y, I got to plug in something for x. Okay? That's kind of the idea there. And another quick reminder, what does slope represent, right? It's kind of down here. It's the change in y over the change in x. So we also write that as rise over run, and how much are we changing in our vertical direction versus how much are we changing in our x direction. And so we write that as y2 minus y1 over x2 minus x1. And just as a reminder, it doesn't matter how you label your points as long as you're consistent. Okay. So if you wanted to label this x2, you could, as long as you label this y2. But I'm just going to go with convention, x1, y1, x2, y2. And now you're just plugging everything into the equation. So y2 is 8, so 8 minus y1, which is 6, divided by x2, which is 0, minus x1, which is negative 5. Simplify down, 8 minus 6 is 2. 0 minus negative 5 is a positive 5. So here, this is your slope, which we write as m. So it's a little reminder on how to find the slope of a line, or slope between 2 points. So what is slope-intercept form? We have, some of you probably know this already, it's y equals mx plus b, okay, where m equals your slope and b equals your y-intercept. That's what slope-intercept form is. Okay, so I'll do one more, and I'm going to skip the last one. So again, if you want to find the slope, first thing you're going to do is just label your points. I just go x1, y1, x2, y2. And now you're just plugging everything into this equation right here. Okay, so y2, which is negative 1, minus y1, which is 2, over x2, which is 4, minus x1, which is 5. Negative 1 minus 2 is negative 3. 4 minus 5 is negative 1. Simplify down, negative 3 divided by negative 1 is a positive 3. So m equals positive 3. So now I found the slope between those 2 points. Right, so I'm rising 3, running 1 between those points. And if you're not sure, you can always graph it, right? Put the points on a graph and see, you can do your rise or run. So you can work on the second one, but I'm going to kind of skip down here at the bottom. I'm actually going to do the middle one first. Okay, so this is in slope-intercept form already. All right, so what you notice is you have y equals mx plus b, right? So your number in front of your x term here represents your slope. So here, find the slope, m equals 5. And b is your other term. It's over here. This is your b term. Now, here, normally we have a plus, but now we have a minus. So that means our b is going to be negative 3. So as a point, as a y-intercept, remember your y-intercept has a x-coordinate of 0, and your y-coordinate is negative 3. So on the first one, if we wanted to find the y-intercept, we could plug in x is 0 and then solve, right? But I'm going to find the slope anyway. So what I'm going to do is I'm going to make this, turn this from in this form, in standard form, into slope-intercept form. So the first thing I'm going to do is subtract x. So 3y equals negative x plus 9. That's by subtracting x on both sides. Now I divide by 3, and I get y equals, there's a 1 in front of this x, Okay, there's an imaginary 1, so I'm going to have negative 1/3 x. Right, 1 divided by 3 is just 1/3. And then 9 divided by 3 is just 3. And again, the reason why I did this is now once I'm in slope-intercept form, it's pretty easy to see what the slope and the y-intercept are going to be. Right, your m is negative 1/3. Your slope b, or sorry, your y-intercept is going to be 0 for your x coordinate. Your y coordinate is right here, 3. And so now I got my slope and my intercept. All right, moving along to the next one. We have y equals negative 2x plus 5. And again, if you want to label these, here's your slope. Here's your y-intercept. Remember, your y-intercept has an x coordinate of 0. Your y coordinate is just what you see as your b term. Okay. And so 0, 5 is going to be on my graph. 0, 1, 2, 3, 4, 5. And now my slope is negative 2. And if you want to write that as a fraction, you can write that as negative 2 over 1, right? If you want to see rise over run. So I'm rising, well, I'm not rising, I'm going down 2 and I'm moving over 1. So when I graph this, I'm going to start at my point, go down 2, 1, 2, move over 1. Down 2, over 1. So once you get a couple points, you can go in here and put a line. Okay, make sure you put arrows on the lines because these go on forever. You can label some points here. This is your y-intercept at 0, 5. We got a point here at what is that? 3 or 1, 3. Okay, you can label some more if you want to. All right, so now we've taken this. Once you get it into y-intercept or slope-intercept form, sorry, it's pretty quick to make a graph. Well, I want you to think about what graphs look like when they have a negative slope versus a positive slope as well. Right, that'll help you as well recognize if you did something right or wrong. On the next one, I'm going to get it into the same form. So 2y equals negative x plus 4. Just subtract out over the x, divide by 2, and I get y equals, again, there's like an imaginary 1 here, so negative 1 over 2 x plus 2. All right, here is my slope, so m is negative 1/2. I'm going to label things. Here b is 0, 2. So I'm going to start at 0, 2, put a dot here. I'm going down 1 over 2, put a dot there. Right? And this pattern continues. I can also go up 1 over 2 the other direction. And it goes right there. And you can connect these and label these points. Something like this. So now you kind of graph those lines. Okay. And what you notice, you can kind of graph things multiple ways. If you want to do it with intercepts, you could have found the intercepts and plug those in, right? But this is doing it with slope-intercept form. All right, so last question. I'll run through this. So we're looking at a submarine, and it's going to start looking at the ocean floor, and it starts to rise. And so we got a function right here, where t is the time in minutes, and it begins to ascend, so it starts to come up to the surface. So graph the function, identify its domain and range, identify the slopes and the intercepts of the function. I'm going to start with the second question. I'm just going to identify the slope and the intercepts. So because we're in y or slope-intercept form, right, we know our slope is right here. It's next to your variable, so 650. So m equals 650. Your y-intercept is your b term, so you have negative 0, negative 13,000. Okay. Now we're going to do a couple things here, and it tells us to also find the domain and range. All right, and so I want you to think, okay, if you're the submarine, right, and you're ascending to the surface, okay, what is the maximum value that our y could take on, that we can be in the water, right? So we can't be in the positives because we know that our submarine is gonna stop once it reaches the surface. So what I can do is I can set this equation equal to 0. Okay, and now I can just solve for t. So if I add 13,000 to the other side, you get 13,000 equals 650t. Divide by 650. And I get t equals 20. So it takes 20 minutes for our submarine to reach the surface. And you're like, well, you might be thinking, why did I do this? Why did I set this equal to 0 and solve for t? Because now what I said is that when my y is 0, my t value has to be 20. And so there's my other intercept. Okay. So what I'm saying is that as your submarines, if you're looking at this on the graph, okay, as you're looking at this on the graph, where you're starting, a kind of rough picture, you're starting down here, right, and you're going up until you reach the surface of the water, which is, somewhere over here, okay? And so basically what we're saying is that it's going to take us 20 minutes at most, or it's going to take us 20 minutes to reach the surface of the water. Okay, so now we're going to have so now we have our intercepts and we got some stuff that we can graph with. So now let's make a better actual picture. So I'm going to put some axes on the graph there. So this horizontal red line at 0 is going to represent your surface of the water. And so we know we have a dot at 0, comma negative 13,000. Okay. All right. And basically we know our slope is 650 over 0, or we can go to 20, comma 0 as well. Okay. So this is 20, comma 0. This is 0, comma negative 13,000. And now I can connect these two lines. And I have a graph for our equation. Okay, so now this is kind of the rate at which we're ascending back to the surface. All right, guys, that's it for this video. As always, if you have questions, please let us know. If not, have a great rest of your day.